Hello, we're going to do notes number 2, limiting reactants. This is for modern chemistry. So limiting reactants and excess reactants. The definition of limiting reactant is the reactant in a chemical reaction that determines the amount of product that can be formed. It's the limiting factor. And the reaction stops when all of the limiting reactant has been consumed. A great final exam question is what happens when you run out of one of the reactants, but you have an excess of all the other reactants, the reaction stops. ER stands for excess reactant. It's the reactant in a chemical reaction that remains unreacted when a reaction stops due to the limiting reactant or factor. You'll be asked to determine the amount in grams or moles of the excess reactant. Actually, I will not ask you that part. The honors chemistry kids need to know how to do that. How can you identify a limiting reactant problem? You will be given the amounts of both of the reactants. So here is a reaction. I would give you the amounts of N2 and H2, and that's your clue that it's a limiting reactant problem, and you have to do a little bit more work before you can answer the question. So for example, if 28 grams of nitrogen gas react with 25 grams of hydrogen gas, determine the amount of NH3 produced. So the question is asking you how much of this you can produce, but you're given the amounts of both of these, and you have to find out which one you have in the limited amount. And just because you have 25 grams of hydrogen doesn't mean it's the limiting factor. You have to change to moles, and in chemistry we always have to compare moles because each reactant has its own molar mass, and therefore you'd want to determine the number of moles to find which one has the least amount. So anyway, we'll get there. So there's lots of different methods. The method that we're going to do is we're just going to do a line of stoichiometry from each reactant to the product we're trying to find. So in this example here, we would do stoich from 28 grams of nitrogen to ammonia, which we learned that in the last set of notes. And then we would do a second line of stoichiometry from hydrogen to the exact same thing. So a lot of the information we write down is the same, but we can just kind of copy and paste it. And the one that produces the least, so if this one produced the least, then that would be the limiting reactant. If hydrogen produced the least, it would be the limiting reactant. I'm not going to go over the other methods because those are for honors chemistry, or if you want to read through it and you can figure it out, that's awesome. So we're going to look at method 1 here. You're given 55 grams of AgNO3 and you're given 55 grams of Na3PO4. So you're given 55 of this and 55 of that. And it just wants you to find the limiting reactant. But really and truly, in order to do that, we have to find, according to our method, the amount of either this one or that one. And I choose the path of least resistance. I would choose this one as the thing we're trying to find because it has fewer things to add up. So our first step is we balance the reaction. Here we have a 3 there and a 3 there, and what is not written in front of those is a 1 and a 1. The second step, we are, like I said, not given a product to find, so we picked one, and I would pick NaNO3 because I choose the easiest one to do. So step 2B, do stoich from AgNO3 to NaNO3. So we'll start with 55 grams of AgNO3. We'll change it from grams to moles. That 169 number is from the periodic table, an Ag, an N, and 3 O's. Then we do the mole ratio, and these are the coefficients in front of those compounds in the balanced equation. So there's 3 NaNO3s, that's where that came from, and 3 AgNO3s. The one on the bottom is the one you're trying to get rid of, and the one on the top is the one you want. And then now that we get to the NaNO3, we will change it to moles. So we'll change it to grams, from moles to grams, and the molar mass of NaNO3 is 84.99. So in my calculator, I would do 55 divided by the 169 number times 3 divided by 3 times 84.99, and I would get 27.5. So now we have to do the next part if we want to find the limiting reactant, and I'm scrolling to the wrong page here. So here we go. So step 2C is now we need to do stoich from the Na3 to the PO4 to the NaNO3. We've already done a little bit of this work, but let's check it out. So 55 grams of the Na3PO4, change it grams to moles. Do the mole ratio, there's one of those for 3 of those. And then we'll change those moles of NaNO3 to grams. We could have just copied and pasted from the last time we did this. My calculator, 55 divided by the 163 number times 3 divided by 1 times 84.99 gives me 85.5. So step 3, we have to look at the answers to 2B and 2C and the line of stoichiometry that produced the least amount of NaNO3 has the reactant that is the limiting reactant. So look at the compound that started the line, that line of stoic, and that's the limiting reactant. So for example, AgNO3 produced the least amount of product. So AgNO3 is the limiting reactant. And the other reactant then, Na3PO4, would be the excess reactant if I were to ask you that. So we're going to skip over these other methods since I am not going to ask you how to solve those methods. And we're just going to get to some examples. And let's find those examples. These might be from your homework. So the first problem says, refer to the balanced equation below. So yay, it's balanced for us, and it's a 1-to-1 to 1-to-1. Calculate the amount of PB. So we're trying to find PB that can be produced by given 59 kilograms of PBO and 43 kilograms of carbon. So we have the amounts of both of those. We have to find which one runs out first. And we're given kilograms, which is a pain in the bottom. We have to change kilograms to grams. So I'm going to do a line of stoichiometry from the PBO to the PB, and then I'll do another line of stoic from the C to the PB. And so my first line of stoic here is I'm going to start with the 59 kilograms. Let me get my little pointer again. And then we will change from kilograms to grams by multiplying by 1,000. Then we'll change grams to moles of PBO, and then we'll do the mole ratio. These are all 1-to-1. And then we'll change those moles of PB into grams and change it back into kilograms. So my calculator is 59 times 1,000 divided by 223.2 times 1 divided by 1 times 207.2 divided by 1,000, which equals that. If you figured it out that we could leave out those thousands and what we started in kilograms would end in kilograms, that's fine. So the PBO produces 54.8 kilograms of the lead. Now the next part is that we have to go to do the stoichiometry from carbon to lead. And this particular one, we will start with 43 kilograms, change it to grams, divide by grams to get to moles, do the mole ratio, which is 1-to-1, and change from moles to grams of lead. Calculator 43 times 1,000 divided by 12.01 times 1 divided by 1 times the molar mass of PB, and we get 742 kilograms. So 742 compared to 54.8, that is what this next step is down here, as we compare them. And in our comparison, the 54.8 is the least, so that means the PBO is the limiting reactant, and we type that number in for our answer. Let's move on to the following example with this hand. Too bad they don't have a left hand. For the following balanced reaction, again, it's balanced. How much CnH8O4 can be produced given exactly 12.6 grams of each reactant? So we'll have 12.6 of this one and 12.6 of that one. We'll have to determine the limiting reactant to find out how much of this one is produced. Too bad we're not finding water. It would be so much easier. So we'll start with 12.6 grams of the C7 thing, just because it's first. Change grams to moles. Do the mole ratio. There's 2 C9s to 2 C7s. And then we change the moles to grams of the C9H8O4. And in my calculator, 12.6 divided by 138.12 times 2 divided by 2 times 180.15 and gives us 16.4. Now we need to do the stoic from this one to that one. And we'll start with 12.6 grams of that, because that's what it said we started with. We'll divide by the molar mass of the C4H6O3. We'll multiply by the mole ratio, which is 2-to-1, and then we'll end by changing moles to grams with the molar mass of, it's still that same number. So my calculator, 12.6 divided by 102.09 times 2 divided by 1 times 180.15 gives us 22.2. So now we compare these numbers. The least one in this game, a little bit like golf, will win. And so we put the 16.4 in there. We started with 3 sig figs, so we'll end with 3 sig figs. Here's the last example. For the following unbalanced reaction, how much COCl2 and how much HCl, oh my gosh, we have to find both of these, can be produced from exactly 11.3 grams of each reactant. So we're going to have 11.3 of that one and 11.3 of that one, and we're trying to find out how much of each one. So it says a hint, people. Let's look at the hint one. Hint, balance the equation. 2, find the limiting reactant, and then 3, use the limiting reactant to find the amounts of both products. So we got to balance it. There it is, balanced, a 2, a 1, a 2, a 2. And then I will start by doing stoichiometry to the easiest one, which is HCl. I'll do stoic from there to there, and I'll do stoic from O2 to there, and the one that is the least will be the answer I put in there, and the one that's the least, the thing it started with, will be our limiting reactant, and we'll use that to find the COCl2. So the stoic from the CH3, 11.3 grams, change grams to moles. Mole ratio, it's a 2 to 2, and then we'll do moles to grams of HCl, and we get 3.45. Calculate 11.3 divided by 119.37 times 2 divided by 2 times 36.46. And then we have to do stoichiometry from O2 to HCl. And that will look like this. 11.3 grams of O2 will divide by 32 grams, because that's 2 O's added up, a mole ratio of 2 to 1. And then we'll multiply by the molar mass of HCl again. So 11.3 divided by 32 times 2 divided by 1 times 36.46 gives us 25.7. So we're comparing 25.7 and 3.45. That one is the least, so that's the number that goes there. And then we go all the way to the beginning. That was our limiting reactant. We will use that limiting reactant then to start the third question, which is how much of COCl2 can we produce. So we'll start with 11.3 grams of CHCl3 that was given, change it to moles. The good news is that we have already figured out some of that stuff. It can be a little bit of cut and paste. Mole ratio of 2 to 2, and then we'll change those moles of COCl2 to grams, and we get 9.36 grams, and we swing it up there and plop it in that box. 3 sig figs, started with 3, end with 3. I hope this helps you a little bit with limiting reactants. It is really can be a confusing process, and there's multiple ways to do this. I showed you one way that is the most reliable and hopefully the least confusing for you all. I hope this distance learning is going well for you, and I will see you sometime in the future. Ciao.